So I'm going to talk about applications. This is probably, I think, the only slide that just has words on it. So, and I'm not going to read through them, but we have done, I would say, low-level stuff with GIS for EWB because that's what served our purpose. Most of it is making maps. You know, we need to see things a certain way, prepare maps for our trips or reports, or for planning, looking at layouts on things and getting an idea and sense of things. Because again, our brains work well when we look at maps. So the primary thing, maybe 75% of it has been just making maps. And secondly, it's a way of storing a lot of this data all in one place that we can get back to again. So some specific things around the project. Centennial Secondary School, we have had the longest history, so we have the most data in our GIS. We've used that for system layout and doing distance measurements for piping runs. I think when we put the water lines in, we weren't quite GIS savvy yet, but in the later phases, looking at electrical runs, certainly in this most recent trick, using the GIS for that. We built the campus boundaries. I'll show an example of that. And one of the things that we have to finish up now is, since we've put all of our planned work into a GIS, go back, use that to make our as-builts for a lot of the plan views for this stuff, which at Centennial School involves a lot of buried electrical and water lines, so it's very important that we have a good record and that the school has a good record of where that stuff is. Matru Hospital, just starting out there, we're using this to lay things out. Where do we put stuff? I'll have an example to show that. And in Dominican Republic, it's been really important from the standpoint of hydrology and elevation and looking at which way water flows, right? Because we have a gravity-fed water system, and so the terrain is critical in planning the pipeline routing. I'm going to step through a couple of very basic examples then. So we'll start off with just because it's a kind of a good one to look at. So the boundary of Centennial Secondary School is a problem. When the school was built, it was in the middle of the jungle and there was nothing there, and no one probably even thought about the need for a boundary. But then as Matru began to grow, and particularly in recent years, in the recent decade, houses have cropped up all around the school. There's been a lot of land loss, encroachment on the perceived boundary. So in 2008, the UBC Church commissioned a survey, and we got this survey, and so now we have a map of the boundary. We're all fine, but it doesn't really tell us like where that boundary is. Of course, we're particularly interested into like where is it relative to the school buildings themselves and other things on the school. We don't know how it was created. We certainly don't know how accurate it is. Yes, Chris, sorry.
How would that survey have been done in 2008?
I'll talk about that.
Okay.
So there's guesswork. So that was my first question. How was it created? It'd be wonderful if it was done. Somebody showed up with 21st century equipment. They had a total station, and it was linked in with satellites, and they had a base control reference point, and they did all this stuff. But we know that didn't happen. So it was probably done with traditional, transit survey equipment, and they measured things off with a tape and made their segments that way, and used a compass for their directions. Guessing though, we don't know for sure. We have this map. It has distances along segments and bearings, but we don't really, first of all, know where it is. So this is an example of something that's not georeferenced. Matter of fact, unless coordinates are placed on a survey, surveys aren't georeferenced data. They make a map, but they just sit out there. So we have to figure out where it is. And so you have to really do, well, really four things, but I'll say three things and just allude to the fourth one. When you have this boundary, we have to know, first of all, what's its scale? Okay, is it that big? It's 3 inches apart or 300 meters apart? Now, since they did take measurements along the segments, to the extent we trust that, by the way, their bearings don't quite make a polygon, so we don't entirely trust it, but to the extent we trust that, we have a pretty good estimate of scale. Second thing is rotation. Well, which way is it oriented? Well, okay, they have bearings along all those lines, but what are they using true north or magnetic north? Well, you can't measure true north directly. True north is where the North Pole is and the Earth's axis is. Magnetic north is where your compass points. They're not the same place, and they change everywhere on the planet, and they change over time. So the magnetic field of the Earth is moving around. And even though there's pretty good ways of estimating where they are at a point in time, there's still an estimate. I find that the local area is significant. Actually, I've had personal experience doing this where it's been a couple of degrees off. So if those measurements are measuring true north, it means they corrected it using some estimate, which may or may not be correct, overlaid with whatever error they had on making the measurement. That's the rotation piece. We have to turn it the right way. And finally, we have to position it. So it can't just float in space. We want to get it back to a reference point. So somewhere on there, we'd like to have one point we can say, this corresponds to this latitude and longitude in this datum in Matru. And so that's the exercise. There's a fourth thing that you have to do in transforming these things generally because of that projection issue. And that is, the Earth isn't flat story. So to some extent, you have to rubber sheet it, kind of stretch it in the right way. And for that reason, you need to have a couple of reference points to do that. Generally not a big issue over something that's like less than a square kilometer. So that's what we want to do, and we want to put it into our GIS. So we assigned this to a crack team.
I'm just curious, what sort of reference point did they use?
There is very little on here to tell us where this is. The question was, what reference point did they use? So when you're doing a survey, you can just be self-referencing. You can say, it's this long from this point to this point to this point to this point. Here's my map. Thank you. So it's not necessarily possible to link that to anything in the real world unless it identifies things. Sometimes in surveys you're used to seeing when you actually go out to like a plot where people have put pegs in the ground and they put a stake there. And so that's good because that probably doesn't move. Sometimes in old surveys it's because the oak tree was there back in 1843. And then you're kind of screwed. So here, the only thing on this map is they refer to a building here and a distance to that point. So that became our target. At least that was the intention to reference this thing.
Good.
Oh. Okay. So when the team traveled in March of last year, 2 years. Well, a year and a half, okay, March of 2016, we took that survey map and I marked it up basically so that the team could walk around with an inexpensive, low-grade recreational GPS receiver, which we've used for almost all of our stuff. And actually follow this boundary to the extent they can find it. As it turns out, there's a lot of markers along the way, and take GPS readings there. Now, lots of error in that kind of GPS reading. They'll tell you it's 10 meters accuracy. It's really more like 10 feet, but and can be pretty good at the right time of day when you have satellites in the right place. But nevertheless, it's noisy. It doesn't pin things down. But with enough readings, combining the survey information with this, the intention was to try to relate it so we could deal with scale, rotation, and position. To the point of position, the one single point of information was this box in the center, which you notice I made in red here and put a description in and explained to Tom and Carl, this is the most important piece of information. But apparently, they walked all the way around, like, I don't know, how many hours did you spend doing that, Carl?
About 3 hours.
And walked all the way around there, but didn't get that information. So that's okay, though. So it made it a better computational problem. So here's from the GIS. Those red marks are the waypoints that were recorded from the team out in the field, and oh, there we go. And so without anything better to do, I pinned it to that corner. Of course, we don't know where that building is down here because that was the point they didn't get. But But we pinned it to that corner. And so if I just took the information from the survey bearings and the waypoints, you can see it's obviously out of whack. The rotation is wrong. It's actually a little bit twisted around. Also, going through the survey information, there was suspect stuff there. Like some of the length measurements were measured in down to the 100th of the inch. So I'm pretty sure that wasn't measured, that was a calculated value by somebody who doesn't understand significant digits. So they obviously did some secondary manipulation of the information. Anyway, this is what we started with. So I did a least squares regression, determined the best fit to get that rotation right. And then it became obvious where some of the data points were just wrong, which was good because initially it looked like the library was not on the property anymore. But with that information corrected, playing around with it, we now have maybe not the official survey boundary, but the best we're probably going to do with, unless we go out there with proper survey equipment again. And because we have all of our other information about where the buildings are, where our systems are, we can integrate that all together. And that's now, at least in our GIS, the official campus boundary.
Is that somebody's house on the lower corner there?
Yes, it sure is. Yeah, there is things on the line or over the line. Something which is also the case nearby at the hospital, where they have the same problem with people moving in. And we've heard that one of the things that the school has talked about as a future project is building a wall. So not a project that we're going to undertake, and probably has bad connotations now anyways.
I'm just going to say you got to get Congress to approve.
Yeah. We'll build a couple different kinds and see which one they like best.
When we were walking around doing
Yeah.
the
Okay.
points, we actually had to walk through people's backyards in a couple of locations.
Okay. For our GIS, I'm doing all this in ArcGIS, ArcMap. Yeah. So the task before us on this project is where do we put the latrines, and the objective was to put them somewhere near that porch, which is where the admissions is for the hospital. We'd done some soil sampling around that area to look at drainage. And other than that, it was kind of using judgment and dealing with aesthetics and where the water flows and what's going to...
Is that a tree?
That is a tree, yes. That tree has moved. The little green spot there is a palm tree. Actually, in some of the aerial imagery that I had in advance of the trip, there were a lot of trees, which would have been a problem, and we found out that they took many of them down. So such that we can't really even use that. We didn't actually map all the trees, but we mapped that one. Okay, and first I thought it was like near the morgue, which would have been bad for where we wanted to put our cesspit. So we started off with this, went through a lot of gyrations. So this is a combination of some folks on the team actually looking at the physical design of the latrine itself. How do you orient the different stalls, how many there should be, and dealing with, we have to kind of figure how we service men, women, and children, combined with how we orient it and put it in that space that we have available. The hospital was not saying, we want the latrine right here. They were saying, we want a latrine that services the admissions porch. So we could play around with all of that, and ultimately located it. And so this is the proposed latrine, or the planned latrine location. Now it is on the GIS. It's panned out, but we have that down, all the measurements. You can see that yellow is the buffering around certain buildings. You have to keep cesspits a certain distance away from things. So that's the plan that we're working with right now. And then beyond that, with this so there's a zoom in on it. So it doesn't look that exciting, but this is pretty much what's going to get built there. This will be the pad. There's swales that run around this building to drain water off. Toilet facility and the cesspit over to the right side there. Beyond that, though, since we have better information, there's an engineer who's residing at the hospital for the next 2 years, Matt Asher, who we're able to communicate with. the hospital is doing some other projects which are really important for us to integrate in and understand where things are. They're putting in a large solar array. They're also putting in a water packaging center. So Matt was able to take our map, sketch in where that stuff is, including interconnects and wiring and things like that. And now we can take that and put it into our GIS, and when we go there, kind of double check and do the same thing we did with the buildings. Is he drew it by eye, and we'll get those locations measured off and pretty accurate. And it's important to do because beyond our latrines, one of the big projects we expect to undertake is to move this build a new operating theater, which could be in a space that could interfere with other things. So obviously it's going to be important to know where everything is. Yeah, question?
Those trees that are near where the latrine is in that little open space, they're not there anymore?
Yeah, the trees are from former aerials, and as I said, they've done some major clear cutting there. So a lot of the trees are gone.
Where's the aerial? I don't remember that many trees there, maybe years ago.
When we
This
photographed from the road, and
this
there
is
was a lot of trees in that general vicinity.
Really? Okay.
yeah, it's we don't have proper orthorectified aerial imagery of this area, so this is just going out and I'm taking images from Google Maps and rubber sheeting it over things, and that's how I drew in what looked like blobby trees. Okay. All right, now the final example I'll talk about is some of the things that have been done with the Dominican Republic, and particularly around elevation profiles for the water pipeline routing. And one of the really fortunate things we couldn't take advantage of in Africa, but could in the Dominican Republic is there's a couple of half-decent digital elevation models. And what that is in the United States, and in this case actually covering Dominican Republic as well, NASA and the USGS has a wealth of information from satellite imagery, multispectral analysis, and elevation information. And what they're doing is they're just flying satellites over and shooting laser beams and bouncing off signals, and that's LiDAR. And they get a distance, and they can calculate the elevation there, like within centimeters. And then with all that information, they do a next step of processing to make it very useful for people who don't want to go through that much information. They create raster models that allow you to represent things like this. So now this is an image that I created from their digital elevation model. Doesn't look like anything, it's data. But it's represented as a raster surface. So this is these little grid squares. If you zoom in here, you can see a little bit of the pixelation, but if you zoom in, I'm not sure if that comes out real well, but you see the little squares. So that surface is really represented by these little squares that have an elevation assigned to them. This model has a 30-meter resolution, so that means 30-meter square area is all assigned one elevation, then the next one over is assigned another elevation. I did a little bit of post-processing of my own on this. So this is 30, this is a zoom in area. This is 30 meters here, but since I know that things near each other are more likely to have things in common than things that are far away from each other, I did some resampling. So basically, I kind of smoothed it out as you go a little closer to the next one. So that's not making the data any better, but it's making the surface look smooth, like it's not like has a bunch of steps all over it. So with this digital elevation model, this is gold. And by the way, most places in the United States, you get actually really good stuff. For my father's land, the information is 1 meter resolution. I mean, we can see old logging trails that we weren't aware were there from these digital elevation models, just because of the subtle nuances you can pick up. So some of the information, the wealth of information available through USGS National Map has a lot of stuff in the U.S. Fortunately, the satellites were turned on over Dominican Republic at some point. The satellites are turned on everywhere in the world, but you have to be in the military to get that information. So with that, now we can start doing all kinds of stuff with this. I'll call it a DEM, digital elevation model. Things you look familiar, you can make topographic maps. So I created created that from the digital elevation model. It's interpolating that information, finding common line contours. It's a little bit crunchy there with sharp turns. We can smooth that out. It makes it a little bit more wrong, but more pretty. You know, we're kind of adding information to a raster data. But so we can create that kind of stuff, which we do, and can incorporate that in our field. Those are houses, and they look goofy because they are represented in the GIS as a polygon that actually came from OpenStreetMap and then was field verified. But in a 3D rendering, I've said, okay, I'm going to make them little boxes that are this high. So I just stretched them out a little bit. Again, all maps are wrong. It's like a model. All maps are wrong. Some are useful. You can do those kinds of things. So some of the things we do with this, and Bill is very familiar with this, one of the things that has been a big concern is the salinity of the water. Existing wells have showed various amounts of salt content, and that would be a bad thing if a well that's drilled has a high salt level and tended to be used for drinking water. And so as part of the previous trips, Bill collected, or others collected, conductivity data from those wells to measure salinity. And the intention was to try to understand there's some relationship with the location, the elevation, location relative to the river particularly, and elevation of these things in regard to the salinity. And we couldn't, not nearly enough data points to do kind of like any kind of broad surface mapping around that. But looking for relationships, and I think the answer was not an answer here. You know, there was not a wonderful pattern that popped up and said, drill here and you'll be fine. But this is the kind of thing that we did look at. The main thing, though, that was of importance for this project, since it was to lay down kilometers of pipeline that had to get pumped up to a tank and then flow downhill to everybody who's going to use it, is understanding this terrain for these gravity-fed systems. So that digital elevation model allows us to do those kinds of slope and elevation analysis directly from the GIS. And so that's exactly what we did. Worked interactively with particularly Kathleen Gallagher, Bill, other people at Langen, who were looking at different options for laying things out. And it was kind of interesting because for the most part, the designers were working in AutoCAD, and AutoCAD and GIS shake hands, but kind of like Democrats and Republicans shaking hands across the aisle, not very friendly. So things are confused in the mix. So we were working back and forth between AutoCAD and GIS to do this stuff. But I could take a planned route from AutoCAD, pull it into the GIS, and do this kind of elevation profile analysis. And get pictures, but also get data so we can look at that kinds of stuff. So once you do this, then you can pull this stuff down and start looking at, for different line segments, what's the min-max elevations, the slope. Also, in addition to that, you can faintly see this blue buffer around here. So we knew where all the buildings were from aerials, but some of the field verification was identifying which buildings were homes. So we actually have a count and a location of where the houses, the people that are going to use the water, are. And so within those buffer zones, then, we could assign houses to a particular segment of the water line and look at how much water they were pulling off as it goes down the line to get the kind of the cumulative house serves and the flow fraction. So all that stuff, elevation drops, the flow, all could be then was used to build out the pressure drop model for the flow calculations. And then goes back into AutoCAD. So ultimately, we end up with a design drawing that looks like this, but that is in sync with our GIS information. Okay, I think that is all I've got. I just wanted to have a brief mention about some future things that I think we ought to do and can happen now with a little bit of work. So far, you know, I've been a bit of the weak link here because I have the only tool that can get to our data, so that's never a good thing for our organization. So we could get a few other GIS people in here, that would be great. But I think what we should do no matter what is we should be looking at some cloud repository for this data. And that's the direction of the world anyway now. Certainly though, when we do that then, for a lot of the everyday stuff that EWB uses this information for, making a map or looking at something, everyone can do that. And it's not with using any kind of complicated tools or multiple emails. You just go out and do it. So I think that will satisfy a lot of the needs of the chapter and something that we should plan to do. And along with that, some of these things, like even Google Maps has pretty decent tools to do some basic stuff.
Where's it stored now?
It's stored right here
Okay,
and backed up. Okay, so all this GIS processing has been done with ArcGIS Desktop, and that's so again not a good situation for an organization. So I think moving it to some place where we can all get to it. I think there's still maybe some high level things that we have to go into a desktop tool like ArcGIS to do things, but so much stuff is really just let's get this view or figure the distance from here to here. Yes, Chris, question.
Is the data in a form that only ArcGIS can access, or is it accessible and usable by some of the open source or maybe other types of applications?
Well, all of it can get from here to there, so it's like communicating with AutoCAD. It can shake hands, but that requires some conversions. From ArcGIS, I can put it into any file format and make it useful for something else. So migrating it, once we choose on what kind of platform, migrating it there is there's no technical barriers to it. We'll probably, if we intend to move like lots of stuff, it may be problematic. But some of it has to do with the decisions on what information we want to get out there and how we want to share it. I would say that, yes, Chris, go ahead.
Yeah, part of the problem that I see is the expense of ArcGIS. So as an NGO, or a nonprofit, do individuals within our chapter qualify to buy that $100 option for ArcGIS?
So the question was around licensing of ArcGIS, and as I mentioned before, they have very, very attractive user licenses for nonprofits and educational organizations. So I think it's like $150, and you get everything.
Is that like a license for an individual?
That would be an individual single user license. Yes, yes. Now, of course, they also like commercial users usually have enterprise licenses, so they can put it on a server and they have multiple users. And again, the shift now to make all those things kind of go away is to get things out of the cloud. So Esri is moving ArcGIS to an online. They are pushing this very, very hard. They're building up the functionality of the online stuff. It's a little bit, it's a different business model. So there won't be a $7,000 initial user license fee, which is what it is, by the way. But there'll be some kind of subscription service. But I think actually the ArcGIS Online would be the most direct way. I mean, matter of fact, I could be there in like a couple of weeks with everything and putting it out there. I'm not sure what we can do from the standpoint of what a nonprofit organization pays for an online license and all that kind of stuff. Those would be the kinds of things to be worked out. But that would be one possibility that would probably be the least disruptive in terms of taking everything we have and putting it there. The downside, and it is even the online platform, although it doesn't do what desktop does, it has a lot of functionality to do many, many things. It's also going to be the least familiar to people, though. It's, ArcMap, ArcGIS suite, it just has so many bells and whistles, it's a little bit overwhelming. But that would be one thing to look at. Second one is kind of obvious, is Google Maps. Google Maps has a GIS behind it. You can do a lot inside Google Maps other than finding directions to things. You can create your own mapping tools. I had my solar eclipse line all mapped out when I was driving there, so I could actually drive to the directions and I could see how close we are and all that kind of stuff. You can build that kind of stuff out in Google Maps. Doesn't have nearly the functionality. All the formatting stuff and pretty pictures go away. You get what Google decides it's going to look like. But I mean, you can change the color and shape of things. You can do many things within it. The thing is, though, it's very familiar to people. So in that respect, I think it would be a useful thing to do in addition to anything else we do, just so that we can share information readily.
Can you use ArcGIS to write out the KML file so that you can load that into a standard Garmin, recreational unit?
Well, I do that all the time, but generally you're going to use it as a GPX file into a Garmin.
Yeah.
That's what Google Maps does for you with their KML files.
Right. Okay.
So all those kinds of things are interchangeable. That's like that's simple point vector information. So it's kind of trivial conversions, and all those tools are available to move from one to the other. From ArcGIS, you can make it anything. Once to get it back into there, you have to maybe play around a little bit.
John, as we're going along here, I'd be interested to know what kind of data would be useful for us to collect. We are writing some information, some instructions to contractors and to people, constructing this for us. What information might be useful for us to collect as like the pipelines are being installed or things like that might be useful for us later on?
So the question was, what kinds of information might be useful to collect for the GIS for the Dominican Republic project? So that's really a question for the project team to answer. I mean, because you know the utility of that information and have some thoughts on what you might want to do with it in the future. If it's any information that has a location assigned to it, it can go into the GIS. Certainly, as the pipelines are put in, getting the actual locations of where they are, which may or may not be exactly where the plan said they were going to be, is going to be very imperative. So before the grass grows thick over those lines, while they're laying them, that would be a very good time to get very good information all along the way of those routes, so we have that information very precisely.
Would that be like, could we go from like a phone to a Garmin to a Trimble or whatever, taking a phone picture?
Well,
useful.
Okay, so the question was, can you take a phone picture? Well, I think you get a real good picture on a really crappy location from that. Your phone GPS receiver is not very good. It's not even as good as the Garmin recreational units. So these aren't places, if you want to know, well, it's somewhere around here, that's good. If you want to know, dig here, you're going to have to do better than that.
I think there's a workaround for that, though. If you do use the the high quality GPS unit simultaneously with that photograph, they'll have a timestamp on it, and you can coordinate those timestamps to that photograph in a very precise location.
Well, the time, okay, so the suggestion is using the timestamp information from the photograph. I mean, any GPS receiver data point you get is going to have a timestamp on it. Timestamps just tells you how good or bad your information was at that time. So if you told me you collected a piece of data, last Tuesday at 3 p.m., I can go and look up the satellite positions, and you get a degree of precision from that. So if it happened to be that you just had your lucky day and you had 13 satellites in the sky, your precision is much, much better. So that's the kind of thing, the timestamp. It doesn't improve the quality of your data.
What I was getting at, though, is if you use your research GPS simultaneously with the photograph you take with your phone, you're going to have because of that timestamp, you're going to have a much more precise location than what you would get with the GPS data out of the phone. Because you're interested in what's that picture. What is it telling you? Where's it at? That's what you're interested in.
Okay. Yes.
Does EWB National have any guidance? Do they use this? Do they have a direction on any of this that he's talking about?
question, does EWB-USA National have any direction and guidance on GIS? Not that I've been able to determine. I had one communication with them about 2 years ago on this, and there were about two things. First of all, about access to Google Earth Pro, which became a non-issue because about a month after that, I think, is when Google Earth Pro became freely available to everybody. Google Earth Pro just has some extra features, and so if you use Google Earth, you want to download Google Earth Pro. Well, you can, because that's not going to be available for long. They're moving to online platforms too. Regarding ArcGIS, they supposedly were trying to get some kind of organizational license, but I never heard anything more about it, and I don't see any evidence of that. But I don't really see the point of it either, because I think that's already been done because of the way that ESRI has structured their nonprofit licensing. We have access to it freely. The thing that I would like to learn more about is, does that extend to an online licensed platform? And as a nonprofit, would we have the ability to do a lot of the online stuff, which we would want to be able to get our hands on? If that's the case, if we can do that for $150 a year or something like that, that would be a no-brainer, I think, to do that, because it would just open the door to this for everybody in the chapter. Some of the other things, so besides ArcGIS and Google, which are really, well, ArcGIS is a GIS tool. Google Maps has some GIS functionality. I mentioned OpenStreetMap, which is not a GIS per se. It doesn't have tools, but it's something everybody already has, and we are using it, and so we should just say, yes, we're doing that, and we should be consistent in how we do it. Pretty much when we have any confirmed information about where roads, buildings, and structures are, I put them out in OpenStreetMap. I have to catch up with that on the hospital. So that becomes publicly available, and that's just a good thing to do, and we should do it as a chapter. We should recognize that and use this as a good tool to go out there. If you want a quick view of the layout of Centennial School, go out to OpenStreetMap. It's the same as in ArcGIS, because that's where it came from.
So in a place like Nigeria, you'd be able to get OpenStreetMap there?
Well, OpenStreetMap is a software tool that's crowdsourced. So it has data in it if somebody put it in there. And people have put it in there for Matru, and I've gone in and improved it where we've had better information. So the pictures of where buildings are and the boundary that you'll see for Centennial Secondary School came from our work. It's a representation of our ground field data, verification, and that's what OpenStreetMap allows you to do, is go in and add things or correct things. And so we should just do that consistently for all of our projects, because that way, again, any chapter member can open up OpenStreetMap and have current information. And secondly, we're also benefiting that community with making that information available to other NGOs.
Okay. What is the FOSS?
Oh,
Thank you.
free and open source software. So ArcGIS and Google Maps are not free and open software. And free and open source software, it's free as in free speech, not as in free beer, is what they say. It's free as in you can go into the code and change things and adapt it to suit your needs within whatever license terms they've established. You may actually have to pay for it. Now, actually, you don't have to pay for OpenStreetMaps, because it is also free as in free beer. But when we talk about free and open source software, it's stuff that you can go in and change. You can't do that with Google Maps. Google owns that, and they're not going to let you screw around with it. But other things you can. So, like a lot of the web developer stuff, web developers are using OpenStreetMaps in their mapping systems for that reason, because they can go in and write their own code and mix it up and pull things in. And so there's a lot of other free and open source platforms that are worth looking at that may actually even use OpenStreetMaps or the Google API in their systems and provide tools that we could play with. So this is an area that I would just have to in my leisure time explore, but there may be some more ready-made solutions that we can also look at. And I think what we're going to end up doing is some combination of these things. And I don't rule out building our own. So for example, if we just say we're going to use Google Maps, we don't have to necessarily do it in the Google Maps platform. We can use their API. In other words, we can use, they provide web developer tools to allow you to use their stuff.
What's
And
API?
what does it stand for? I'm not going to be able to give you that
It's
acronym.
Application Programmer Interface.
There we go. Okay.
What's the first word?
Application.
Application.
Thank you. API, Application Programmer Interface. It's the way two pieces of software talk with each other. So you can create something in a Google Maps system, but then connect that with another web page or another piece of software and interact with it. And that's not that hard to do because all these tools are out there. You kind of have to get up to speed with them. But I wouldn't rule out building something on our website, for example, that makes use of some of these online platforms, but pulls it into a format that we like, that we have ready access to. That might happen on the EWB web page. I also have a web page that I could set up something. We could have our own deep website with all our secret project
Why would we
information.
do that? What's the advantage of that over using?
We can set up any way we want and really have control over it. So, and I would say that's like after we do some of the low-hanging fruit things. But we should go down one of these routes or maybe a couple of them now, because I think that it's not really appropriate that anytime somebody needs a map view that one person has to go into ArcGIS and pull data out. That kind of basic stuff we should all have readily at hand. I think it'll really help our productivity, and it's the kind of stuff that everyone in the chapter should be able to do if we put it on the right platform.
Are you familiar with maps.me?
I've heard of it.
I've been using
maps.me was the question.
It seems very accurate, and my question is, well, if you haven't seen it, you wouldn't know how easy it is to take the information we generated and put it into a maps.me.
So maps.me, I think that's, I don't know if it's on Android, it's an Apple application. There are thousands of them, and some everyone kind of has their favorite. They play with things and do things. I've got more on my phone than I have even opened because I just loaded another one the other day because it interests me. Those are all doing this kind of thing. So they're not, you need the data. A lot of them are using existing tools like Google or OpenStreetMap as an interface.
Talks to OpenStreetMap.
Yeah.
Does it?
Yeah.
Okay.
So that's like, there's so much going on in that space. So there may be things to do, but I think it might be interesting to have it on a phone app, but we also need to be like internet based. So any device, anywhere people can get to. And that's my reticence about relying on a phone device for a phone app for something like that. So I guess I'll leave it at that and just say let's, like in 2018, a good chapter goal is to migrate to something we can use in addition to the more sophisticated tools to make a lot of this information and these tools available to everybody in the chapter. And then I get to say, space, the final frontier. It's true, isn't it, right?
Go after that, John.
Okay, so if we're all good, any other questions before I turn off our audio here?
That was really good, John.
I was
Thank you.
curious on like,
It's been clear.
because you said you could manipulate some of Google Maps features.
Yes, you can put a lot of stuff into Google Maps. You can create your own maps. And so instead of just the regular map view, where's this restaurant I want to go to, you can go and create your own maps, your own Google Maps that you import your own data into. You can pull in information like waypoint data from a GPS or a phone, picture data. You can create lines. You can import Excel files that have coordinates in them and link that stuff to points and carry with it all the attributes and do formatting and things associated with
Do
this.
you have a login for that or something? Or?
Well, you need a Google account. That's it.
Oh,
Yep.
okay.
So there's a lot of stuff you can do. Obviously, I'm sure they have, commercial capability where they can take money from you, but they're happy just to let you play around and share all of your information with them for whatever ultimate goal they have with that. Yeah, and share their advertisements with you. All that is, although Google Maps is not a free and open source software, in other words, you can't change the structure of things, but they do have a lot of capabilities you can do that people really just aren't aware of. And again, that's because once you do that, then anybody with a Google account can go in, we can share that information. I've done a bit of that, and I think some other folks here have used Google Maps to upload information and make their own maps. It's pretty straightforward to do. It's a very, very small learning curve.
Oh.
By the way, it looks like maps.me has your latest and greatest information that you must have put out onto OpenStreetMaps, because it has the locations of all the buildings and everything else at the school.
Comment was maps.me has the current information from OpenStreetMap, and it will, because when we go out and put something in OpenStreetMaps, it's there for everybody. There's a brief verification phase. They have something to do that check it, but it's the value of crowdsourced information. It may not be trustworthy, but it's fast. In fact, I'm part of another group, and I'm not real active. It kind of depends on how busy I am and how interested I am in the crisis. But there's a group called Humanitarian OpenStreetMaps, and I get a report from them every day. Pretty much when there's a problem in the world, like a landslide in Sierra Leone or earthquake someplace, they put a call out and they start mapping. So people just can sit in their armchair and they have it very well organized. There's a project manager, and in a matter of hours, they can get hundreds, sometimes thousands of people going out and digitizing aerial imagery, and they'll give them people assignments. They'll mark off an area and assign grids and say, we want all the roads here, we want all the buildings here. And they'll actually move it around interactively with the response teams to say, they're moving here, we need to do this there. That happens like in days. They can take a part of the world that NOAA maps exist for and create those maps. It started in Haiti. That was really the launch of it. OpenStreetMaps was realized as something that could really be an essential factor in emergency response. So that's a group that's doing that like right away. Our time frame for our projects is measured in years, not hours, but it's the same thing. We can go in and add that data as we need it. Even there can be a team in Dominican Republic and said, they moved the road or something like that. Anybody here can go into OpenStreetMaps and go ahead and make those edits, and it will be available next time they open up the OpenStreetMap on the internet. Any other questions? Okay, I will close out now.
Verify.